humanity has made significant progress in understanding the universe. However, despite our achievements, our knowledge remains limited. It seems that the more we learn, the more we realize how much we have yet to discover. Welcome to AWZ News. And today we're going to look at 10 of the most mysterious unsolved questions surrounding our universe. Don't forget to subscribe and click the bell. In 2012, a significant discovery was made at the Large Hadron Collider. The Higgs boson, also known as the God particle, was finally observed, causing a stir in the scientific community. This particle is a fundamental component of the Higgs field, which remains a mystery to scientists to this day. Despite extensive research, there are still many unanswered questions surrounding this elusive particle. In our universe, there exists a particle known as the Higgs boson. This particle is responsible for providing mass and force to all other particles. Without it, atoms would disintegrate and the universe as we know it would cease to exist. The Higgs boson had been a theoretical concept for many years, but physicists have now discovered physical evidence to prove its existence. However, there was one problem that needed to be addressed. The Higgs boson, which governs the mass and force of all matter, may also have implications for gravity. However, it should be noted that the boson itself is incredibly lightweight. There exist other massive scales that are subject to the force of gravity, much like human beings, planets, and even objects as large as rocks. However, there appear to be some conflicting phenomena between the micro and macro levels. The problem at hand is known as the hierarchy problem among scientists. The Higgs boson's weight is a curious matter. Despite being surrounded by super heavy gravitational states, the boson's mass remains constant and lightweight. This has raised suspicion among scientists who liken the situation to a pencil standing upright on its tip without falling over. It seems like an unlikely and finely tuned occurrence, leading some to question whether there is a natural order to the universe or if it is all just a freak accident. In our daily lives, time holds significant importance. It maintains order and structure. However, physicists are still grappling with the concept of time and its true nature. Some theories suggest that time may not exist as an independent and fundamental concept, unlike our perception of it. While we experience time as a continuous flow from the past to the present and into the future, physics proposes that time may be a part of a larger framework that includes space and other fundamental forces. There exists a theory known as quantum loop gravity. In quantum loop theory, we encounter a theoretical framework that endeavors to merge the principles of quantum mechanics and general relativity. This presents a distinct enigma that we shall delve into in due course. In the fabric of space itself, there exist minuscule loops or threads that interact with one another, ultimately giving rise to the properties we observe, such as matter and the forces of nature. As the topic of discussion shifts, we now find ourselves contemplating the concept of quantum gravity. According to the narrator, time is not a fundamental aspect of the universe. Rather, it emerges as an illusion or approximate concept on large scales. In the realm of physics, hats and glasses are not directly considered when studying the fundamental particles and forces. It is acknowledged that they exist, but they do not play a role in the analysis of these scientific concepts. As the user suggests, there is a fascinating concept that time, as we understand it, could potentially be a result of the interactions between the fundamental quantum structure of the universe. Very well. The user has landed in the solar system. In the vast expanse of the universe, there exists a system known as GW Orionis. This system is a rare gem, for it possesses not one, not two, but 3 stars. As the spaceship approaches the GW Orionis system, the narrator explains that astronomers have discovered that half of the known solar systems in the universe have 2 stars. However, a 3-star system is incredibly rare. In this particular system, 2 of the stars are tightly locked in rotation, while the 3rd star spins wildly around them. The spaceship has landed on a planet that orbits all 3 stars, making it the first of its kind ever discovered. Astronomers call it a circum-triple planet, and it's massive, even larger than Jupiter. Unfortunately, it's a gas giant, rendering it impossible to live on. The narrator notes that the spaceship's passengers are likely disappointed to have ended up so far away from home, especially after being stuck in traffic on the LA freeway just moments before. Foreign in the world of physics, there exists a theoretical substance known as strange matter. This peculiar matter is said to be comprised of elementary particles called strange quarks, which are the very same building blocks that form the protons and neutrons found within atomic nuclei. In the realm of subatomic particles, there exist quarks known as strange quarks. These peculiar quarks have earned their moniker due to their relatively heavier weight and increased instability when compared to the more common up and down quarks found in everyday matter. It is believed that strange quarks may form under the extreme pressure found within the inner workings of neutron stars. In the heart of a neutron star lies an incredibly dense core. The atoms within this core are subjected to immense pressure, causing their protons and neutrons to split apart into even smaller particles known as quarks. In certain theories, it is believed that when strange matter and ordinary matter meet, a process known as strangification may occur. This process involves the conversion of ordinary matter into strange matter. The reasoning behind this is that strange matter is considered to be more stable than ordinary matter and has a lower energy state. If strange matter were to encounter an atomic nucleus, it could potentially engulf it and transform it into a strangelet. The question at hand is whether the universe is infinite or finite. Scientists have long been pondering the nature of the universe. They have come to the conclusion that the universe is expanding, but this raises some interesting questions. If the universe is infinite, how can it be expanding? And if it is finite, what is it expanding into? These are questions that have been debated by scientists and philosophers for centuries. Some argue that the universe is finite and closed, meaning that it has a finite volume and is shaped like a hypersphere or a torus. In a closed universe, if you were to travel in a straight line for a long enough distance, you would eventually end up back where you started. Models of a closed finite universe have been proposed by physicists such as Stephen Hawking and Roger Penrose. A different perspective posits that the universe possesses a finite nature and will ultimately succumb to its own gravitational force, resulting in a phenomenon referred to as the Big Crunch. This concept suggests that the universe's expansion will eventually reverse, culminating in a contraction that terminates in a high-density state akin to the singularity, which is comparable to the initial Big Bang that set everything in motion. Additionally, there are theories that propose the notion of the infinite universe. In the theory of an open universe, the universe is believed to be boundless and infinite, with no discernible boundaries. It is thought to continuously expand without any limitations. As the expansion of the universe persists, scientists such as Alan Guth and Andre Linde have made significant contributions to the field of inflationary cosmology. Their research proposes that our universe could be a mere fragment of an immense and boundless multiverse. Despite the seemingly endless nature of this scenario, collapse remains an unlikely outcome. The Fermi paradox is a puzzling inquiry that emerges from the seeming inconsistency between the strong likelihood of the presence of other civilizations of life forms and the absence of any proof or communication with them. The Fermi paradox gets its name from physicist Enrico Fermi, who once pondered the question, where the heck is everybody? This paradox arises from the fact that there are countless habitable planets in our galaxy and beyond, and the universe itself is incredibly old. Frank Drake, not to be confused with the rapper, came up with an equation called the Drake equation. This equation is a probabilistic framework that suggests there should be many advanced civilizations capable of communicating across the stars. The equation considers factors such as the percentage of star formation, the likelihood of planets existing in habitable zones, and the probability of life developing to a level where communication over vast distances is possible. The Sun, despite being the star at the center of our solar system, remains a mysterious entity to us. Although we possess a good understanding of its general behavior, there are intricacies in its physics that have left many scientists scratching their heads. The incomplete understanding of the Sun's inner workings has an impact on our knowledge of solar flares. The sunbursts have the potential to annihilate life as we know it on our pale blue dot at any given moment. Solar flares are a phenomenon in which the sun's surface releases a tremendous amount of energy, resulting in the emission of intense bursts of radiation and charged particles into space. These occurrences have the potential to affect our technology and communication systems, and even pose a threat to our power grids. Predicting the timing and magnitude of solar flares accurately is a challenging task due to the complex dynamics of the sun in a plasma magnetic field. The magnetic field lines can become twisted or tangled due to various factors, including the movement of the plasma or the presence of different magnetic fields. When these tangled magnetic field lines interact, magnetic reconnection occurs. During this process, the opposing magnetic field lines break and then form new connections with each other. This rearrangement releases a tremendous amount of energy, which can cause explosive events such as solar flares on the Sun or geomagnetic storms in Earth's magnetosphere. As for the possibility of life on Titan, it remains a mystery. For many years, scientists have been captivated by the largest moon of Saturn. This is due to the fact that it boasts hydrocarbon lakes and seas on its surface. One of the most fascinating enigmas surrounding Titan is the chance of liquid oceans existing beneath its icy crust. This raises the possibility of life thriving within them. The potential for life on Titan is centered around the idea of unconventional life forms that differ from those we are familiar with on Earth. These life forms may rely on liquid hydrocarbons like methane or ethane as a basis for their biochemistry, instead of liquid water. The search for potentially habitable planets outside of our solar system has made significant progress since 2010, with nearly 10,000 exoplanets detected as of 2023. This progress is crucial if we are to answer the Fermi paradox and find evidence of extraterrestrial life. The region known as the Goldilocks zone is characterized by its optimal distance from the stars, neither too far nor too close. Recently, the James Webb Telescope provided us with the first definitive glimpse at an exoplanet's atmosphere. The telescope focused on a planet called WASP 39b, located about 700 light-years away. This planet has been described as a hot Saturn, and while it may not be more visually appealing than our planetary neighbor, it is certainly hotter. The Webb telescope was able to detect the chemistry in the planet's clouds, revealing that they do not envelop the entire planet. Additionally, the telescope discovered sulfur dioxide in the planet's atmosphere. As we know, there is a supermassive black hole at the center of every galaxy in the universe, but the formation of these black holes remains a mystery. In the centers of galaxies, there exist objects known as supermassive black holes. These objects are named as such due to their immense size, which can be millions or even billions of times greater than that of our Sun. Despite numerous proposals for their formation, no definitive proof has been established for any of the leading theories. The topic at hand is that of accretion and mergers. Another possibility that arises is the gradual growth of supermassive black holes over time, as they accumulate mass through accretion and merge with smaller black holes. As gas and dust make their way towards the center of a galaxy, they become prime material for a black hole to consume and grow in size. Essentially, the black hole feeds on stardust and becomes increasingly plump. Additionally, there are instances of galactic mergers, where two or more galaxies collide in a stunning display. This collision could potentially bring multiple black holes together, eventually resulting in the formation of a supermassive black hole. In the depths of the universe lie primordial black holes. In the early days of the universe, it is believed that supermassive black holes may have been formed through a process known as primordial black hole creation. This phenomenon could have arisen from fluctuations in the density of the universe during its infancy. These black holes would have started with a significant mass, which could have grown over time through accretion or mergers. However, there are still two significant questions that remain unanswered, much like our Milky Way galaxy. How was all of this possible? What other mysteries are out there waiting to be discovered? Share your thoughts in the comments and don't forget to give this a thumbs up.